In this video, we're going to look at random forest for regression problem. But briefly, I'm going to explain what and how it works, right? So random forest is an ensemble technique that combines the prediction of multiple decision trees. And this would probably improve the accuracy and stability of prediction. Okay, so random forest is widely used actually for classification and regression problems. But let's use an illustration here to see how it briefly works. So at the top here, we have the original data set. So the first step is to kind of perform what we call bootstrap samples. Okay, so the algorithm starts by randomly selecting these bootstrap samples of the training data. That means each sample here is randomly selected with replacement. So it's okay to see repeated data points here, right? And then this process is repeated multiple times, right? Until you generate multiple bootstrap samples. Then the next step is to fit the decision trees, right? So these bootstrap samples are fitted with a decision tree on the sample, right? So again, the decision tree is grown, using the decision tree algorithm, which selects some feature and split it to a point where there's a best reduction in the variance, right? We've already seen this, that of course we'll be able to, variance in the target variable, right? Now this process will continue iteratively until, you reach some threshold. In this case, the criterion here will be maximum depth that we need to specify, right? How far or how big or how large should the tree grow, right? Or a minimum number of samples. And then lastly, we combine the prediction of all this decision tree. It could be 1, could be 10. I mean, of course, it could be 2, could be 10, could be 100, could be 300, right? So to predict a new data point, the algorithm will try to make a prediction using each of these decision tree, right? Then we combine this. So for regression problem, we get the average. Okay, we get a number. For classification, we get the majority vote, right? So let's say we had 10 decision trees, right? And 8 were yes and 2 were no. So majority vote for this classification will be yes. Okay. So having said that, let's now look at briefly what ensemble learning is all about. Now, I like this story of the visually impaired individuals and the elephant to illustrate the concept of ensemble learning in the context of machine learning. Now, in this story, this is how it goes. So we have several visually impaired individuals who are asked to describe an elephant based on the parts of the elephant they could touch, right? So each of these impaired individuals, so for example, this guy, touched the elephant tusk and say, oh, this is a spear. The other one touched the ear, very big at that, and will say, oh, this is a fan. Another one touched the huge leg and, thought this was a tree. The other one touched some part of the stomach and say, this is a wall. And of course, the other guy touched the tail and thought actually this is a rope that you could use to swing with, right? So based on all these individual experiences, right, each of these visually impaired individual, right, forms a different perception or perspective of how this elephant looks like, right? Now, in the context of machine learning, you can see that all these visually impaired individual can be thought of, individual models or classifiers, right? And the elephant here, so there are how many? 1, 2, 3, 4, 5, 6. These are different classifiers. And the elephant here, we can think of this as the underlying relationship between the input variable or independent variable, right, and the output variable. Okay, so each of these models, right, fitted by these classifiers, these individuals, right, has a limited perspective, right, on the relationship, right, and this might affect how the predictions are based on the training data it's seen. Okay. So the idea here with ensemble learning is to combine all this prediction to create a more accurate and robust, prediction based on these individuals, right? Individual model, right? So this is the key idea. We want to combine the prediction of these multiple models. In our case here, we have the individuals here, right? With their different perspectives, thus resulting in a prediction that, could be less influenced by outliers or noise. Again, you know, this just very just helps with illustration, understanding, complete understanding of this concept of the elephant, right? Where we combine individual perceptions, right? This is actually how ensemble, and ensemble is a very powerful technique if actually used correctly, right? With different parameters. Now let's go and look at the implementation of random forest. So now that we've seen what a random forest and briefly looked at how it works and what ensemble technique is all about, random forests are pretty much straightforward. We can actually get that from, so if we go here, ensemble, right? So ensemble here, if I click on that, you can see that's the random forest, right? The regressor. So we import this class from ensemble here. So we import that, and then we create an instance of this class and call that rf_model. Then again here, the max depth here, the number of estimators just means the number of decision trees, could be 100. The default actually is 100. So if I go here, the number of estimators just means the number of trees in the forest. Default is 100. So so in our case, we just leave it as default, right? And then we fit, and then we predict. When we evaluate this, you can see, so I just need to implement that over there. Takes a while. And then when I do this, you can see now this provides us a better performance over KNN, and you know, we're going to run a comparison, but you can see that there's quite an improvement here. So the idea here, the wisdom in crowds kind of like makes a lot of sense. We get the average prediction, right? So again, we'll try one more multi-layer perceptron and see how that compares, and then we will run another code to show the performance summary of all these algorithms we've looked at so far.